Okay, we are back from Mr. Jeffrey's Algebra 2 with Statistics. This course, this lesson may help some other people that don't know how to do this stuff because I teach it differently. Uh, awesome. That reminds me, if you hadn't done yet, so please hit like, hit subscribe, hit the button. Okay. So shh, today we're looking at law of sines and cosines. So what's kind of odd about this? Hey, if y'all are like within 3 feet of each other, use your 2-inch voices. Some of you are like, hey, did you see that? All right. Not really, but y'all get it. All right. Shh. Look, the big letters are the angles, the little letters are the sides. Why it's done like that, I have no idea. Okay. But remember, why a lot of stuff doesn't make sense in math? Drugs. Okay. All right. So, now, believe it or not, the law of sines is actually the easiest one to use. Okay. There's actually less work for it than there is for others. Now, we have this ratio that the sine of each angle over its corresponding side should be equal to everything else. Okay, that is the law. Don't. Okay. So now this right here, it doesn't matter which ones we're given. If we're given all A, all C, they're all supposed to be equal to each other. This is a transitive property. Okay. We're given the measure angle A. We're given the length of angle A. We're given the length of side C. We're finding this. All right, so we're looking for an angle. And when we look for angles, we're going to round to the nearest whole angle. Okay, there should be no decimals in this. All right, so when we're setting up our ratios, this should be the sine of A. So this should be the sine of 70. Okay, that's right here. Okay, that's the only thing you had to plug in. Wow, somebody made your life easier. Okay, so now we got to get the sine of C. Where'd the yellow go? Okay, we've got to get this by itself. Okay, so we're going to have to end up multiplying both sides by 26. Okay, now here's what's odd. And some of y'all, I don't know if they covered this in geometry, and some of y'all, you had a bad experience in geometry, and some of y'all, it's been forever since you had geometry, that you can't divide by the sine of C. You actually have to do something called the sine inverse. Okay, so this is what I'm going to do. I'm going to set this up like we need it right here, and then I'm going to make myself bigger. Okay. And I'm going to show y'all how to put this in on the calculator. Okay. So, clear. All right. So I'm going to do the sine of 70 over 25. Okay. Get that answer. Okay. Now I'm going to multiply it by 26. So just times 26. Okay. Now, it depends on your calculator. You might have to hit shift. You might have to hit second or something. There's a sine inverse, a sine to the -1. In mine, you got to hit the second. It's usually around the sine button. So second, sine inverse. And then I'm going to actually, instead of typing all this crap out, I'm going to hit second and then answer because it kind of copies and pastes it for me. And we get an answer. Okay. So this says it is 77.7. the nearest whole angle or whole number would be 78 degrees. Okay, that's it. Okay, it's very lovely. We like it. It's fun. Okay, kind of easy peasy lemon squeezy. Okay, I know some of y'all are like, wait, that should have been harder. No. Okay, but now I've had students says, Mr. Jeffries, can't you multiply 26 by sine 70? And then, yes, you're going to get the same answer. I don't, potato, potato, people. Okay, potato, potato. All right. Is everybody good with this? Has everybody got this first example? Okay, no. When I said got it, I mean, do you have it written down? Not do you fully understand it? Okay, the sine inverse thing is what got some people. Okay, right? Am I seeing it? Yes. Setting up ratios, cross multiplying and dividing. Okay, look, sine inverse, that's just, remember, how do you undo a square? Square root. Okay, the way that we undo the sine of something is take the sine inverse. It's just a new thing. Okay, and remember, we got to respect everything for what they are. It's new. Okay, all right. So when we are looking for a side, we are going to round to the nearest tenth. Okay, to the nearest tenth. When we're looking for a side, we're going to round to the nearest tenth. Because I don't want to round to a whole number. Probably because all the examples I found, they always say this. And if not, then you break in the law of signs and you go to jail. Yep. All right. So we're plugging it in. We're actually looking for a side this time. Things is going to be a lot easier. Okay. So we're looking sine of A. We have 29. Okay. We have, this is also 29. Holy crap. Is that a typo? No. Okay. And then C is 26. Now, some of y'all are already thinking, wow, you could probably already solve this without actually having to do any math. I know, how many of y'all think you actually know what A would be right now? One person. Okay, this is awesome. This is why I became a teacher. Okay, so get A by multiplying by itself. What did I say? I don't think that's right. Yeah. All right. No. So this doesn't make sense. And I made it. This is what happens when you copy and paste and think it's okay. This is also what happens when you leave before the end of the day and you go vote and then you get a haircut and you forget exactly what you're supposed to be doing the next day. Oh, thank you. Okay, so I would cross multiply, okay, and say this is 26 sine of 29 equals A sine 29, okay? And to get A by itself, I would divide. Now, we actually can divide by the sine of 29 because we're actually finding a length, not, something like that. So if I type this in, I'm going to actually type this into my calculator just like it says. Okay. Yeah, 26. Now, some of y'all probably already figured that out. If I said everything, the sine of this is equal to sine of that. If they're the same angle, it has to be the same side. Okay, so A actually ends up being 26. And this is over here, this is Yes, I did. I actually did it this time. No, I explained that to her later. Yeah, I did. I said, I'm sorry. Yeah. No, I didn't. No, that's beyond my control. Okay. So there's our two examples that we're going to use for the law of sine. Okay. Now, basically, law of sine you can use to find an angle or a side. Okay. And it's ratios. It's cross multiplying, dividing. The new thing is the sine inverse. Okay. That's it. Sorry, I messed up the notes right there. It's supposed to be a sine 29, but I was running out of room, so it got all kind of scrunched together. I'll clean that up. There we go. Now, what's kind of crazy? All this stuff is algebra 2 type stuff. It's actually cross multiply and divide. That's a algebra 1 8th grade, 7th grade standard. Okay, just like we were doing when we were given the graph yesterday of the sine and cosine, we were finding the b. Okay, crazy how that works. Woo! Okay, if you are prone to seizures, I'm sorry for what just happened. Okay, so is everybody good here? Can I move on without anybody like throwing something at me? Okay. Yes. Oh, you're going to pretend to throw something at me? Yeah, I'll listen. I'll pick Jack up and throw him at you. That would definitely be what a teacher's aide is for. Okay, he's going to aid me. That's right. All right, law of cosines. All right, law of cosines. Notice that we are always looking for sides right here. Okay. To me, the law of cosines is kind of like the cousin of the Pythagorean theorem because we're given two sides, we're looking for another side, but we got something else kind of happening here. Okay. So here's the deal. Number one, we're trying to find AB. That's this side right here, which is across right here. So technically, this would be if it's across from big C, it's like little c. Okay. So that's what we're looking for. We're looking for what we need to solve for little c. Okay. Now, as confusing as it is, it's literally a plug and chug type problem. Okay. Just some people may chug faster than others. All right. So let's see. This, I'm going to say now, honestly, when you're setting this up, when you're plugging in A or B or A or C, these things right here, they don't really matter because guess what? It's adding and multiplying. So that doesn't really matter. So you could put, 13 here, you can put 29 here, then 13, and then 29, and then 41. Okay. Now, I'm going to do this part right here on my calculator because I like to do things in pieces. Okay. That's what happens when you grow up playing with the hands on version of Minecraft called Legos. All right, we get 1010, 1010. Okay, so I'm actually going to write one biscuits 1010 right here. Okay, now this other part, okay, some people will sit here and do all this at once. He had permission to leave. Some people do. It's six of one. It's half dozen of another. So some people will say, 2 times 13 times 29, and the cosine of 41. Okay, if I plug all that in, I get that right there. Okay, now I still have to subtract that from 10, 10. So 10, 10 minus. This is where, if you actually know how to do your calculator very well, you're going to be good. I'm going to hit second answer. So we get this, which is, and I know somebody's like, Mr. Jeffries, can't you just type it in all at once? Probably. I'm going to double check. It's been like 2 or 3 years since I've done this. Okay. So if I was to plug all that in, the 10, 10 minus 2 times 13 times 29 cosine 41. Yeah, if I did it all at once, I actually get the same thing. So you don't have to do it in pieces if you don't want to. Now, I'm not going to actually retype this back out. I'm going to hit second and square root and then second answer and get my thing right here. Okay, so I'm going to just draw. I'm not going to rewrite that because that's a lot of jibber jabber. Okay, so I get 20.99. If we're rounding to the nearest tenth, that means we look at 2 of them. This is higher than 5. This is actually going to round this all the way up to 21. So it actually, for this one, it becomes a whole number for the person that wanted to argue with me earlier. So I don't know who that was. Okay. Now, some of you are like, I don't, listen, you have to see what you're looking for. Okay. Basically, think about it. If you're given 2 sides and an angle that's not aligned with those sides, you're going to use the law of cosines. Okay. Because we were given these 2 sides. Look, there's an angle in between them. That's what we're doing. Okay. That's really it. Let's look at number 2. Okay. Now, we're looking for this right here. So this is little a. Look, I'm given 2 sides and an angle between them. That tells me I'm going to use the law of cosine. I can't use the law, getting tangled in the chords. I can't use the law of sines because I don't have this angle over here, this angle over here. Okay. Now, so I'm looking for little a or, BC. Okay. So it's kind of the same process. Plug it in, plug it in. Okay. So 30 squared plus 21 squared. All right. So this gives me 1, 3, 4, 1. And then all this is copy, copy. Okay. It's kind of funny. I know that it sets it up for like A, B, and C and all this other kind of stuff. Basically, it's the same formula, just what are you given, what are you looking for? Okay. All right. Now, I'm going to plug this in. 1, 3, 4, 1 minus 2 times 30 times 21 cosine 1, 2, 3. All right. So from that step, I need another color. I get 2027.24518.4. Okay. So I get that. And then I take the square root of that. I'm just going to say that right there. Okay. I guess when I made this a couple years ago, that looked like a good idea at the time, but it's not. Okay. Kind of like one day, some of these people wearing mullets at school, they'll look back of it and like, All right. So this ends up being 45.02. All right. So if I look right here, this actually ends up being 45. Okay. Now, laws, sine, and cosines, I could actually have made this a lot longer. I know some of y'all are like, I need more examples. Don't worry about it. We're going to get there. Okay. But it's, trust me, the problems I've given you are a lot easier than some of the things that would have been in the book. Okay. The book, not a good time. Okay. I'd rather be, get my pinky toe cut off by somebody with Parkinson's disease using a spoon. Okay. Just, yeah, because they shake. That's not out of pocket at all. Okay. Cut off with a spork by somebody with Parkinson's disease. Well, spork. Spork. Sorry that the spoon to spork was out of pocket. Okay. So, all right. That's all of our lesson today. Don't forget, hit like, hit subscribe, hit the bell. Good stuff, good things. Roll Tide.